He does get a union break. All right. So let's try this. Let's probably pick a woman or somebody who said yes. Don't say anything out loud. Just try to figure it out. Let's see. So tell me, what goes on the bottom? 49. Because who could it have been? Anybody. I love it. I didn't tell you anything about the person, so it could be any of these 49 people. So out of those 49 people, let's see, which way did you do the top here?
27 plus 5.
27 women.
Plus 5 men.
Plus 5 yeses I didn't count yet. Or 27 plus 23 minus 18. Both of those end up in the same place. Please, does that make sense? So this is less of a formula. We are going to write the formula for what we're doing soon. You see how I'm doing all this shit without a formula. Doesn't mean formulas aren't worth anything. For probabilities, the formulas very often get in our way. We try to make the formulas work instead of just stepping back and saying, we just apply the idea of probability. So what did we just say? We said 27 plus 5 eventually, right?
65%.
65%. All right. How are we doing so far? So let me ask you right now, what does it seem that OR means? What do I do for an OR problem? You add. I love it. So I always call OR the nice bouncer. So to get into a club, if the guy's like, you got to be rich, no. You got to be dressed well, no. You got to know the bartender. Oh yeah, it's my friend. All right, yeah. You see that? Or. So if any of those things are true, I'm in. So the number of people that actually get in the bar grows. And is the evil one. And is the one, when I went to the financial aid office when I was a student, we didn't have internets and shit. We had financial aid office. They had this book like this big of scholarships. And you would say, you must be a math major. Check. And you must have a whatever GPA. Check. And you must, check. And you must be a woman. Shit. Because what does and do? It makes less and less and less things match the requirement. You guys switch. That's the evil bouncer. You must know Jim. I know Jim. And you got to be rich. All right. Shit. I'll see you. Right? You guys understand? So I like the and is the evil bouncer. Or is the nice bouncer. I like it. Maybe. Of course, the or bar is going to be pretty full. So you take your pick. So let's try an and question. Let's probably pick somebody who's a man and they said maybe. What goes on the bottom? Did I tell you anything about this person? What's the probability? They're a man and they said maybe. Could they be a woman? Of course. Could they have said something? Yes, of course. I didn't give you any information about this person, so it still is out of 49. I seem to be making a big deal out of the bottom being 49 still.
That's only so it's 22 minus 40.
So the bottom is still 49 because it could have been any of these people.
That's only 3.
Good. How many people match both requirements? They must be a man, so I can only have these people. And they must have said maybe. So there's only 3. You guys see that? And is very often called the intersection. So if I say, what's the intersection of man and maybe? That's the intersection of man and maybe. Right. Sounds like some weird movie from the 60s. The intersection of man and maybe. Huh? So I got 3 out of 49, so 6%. 6%. You guys understand the and? In English, and is confusing. It's not math's fault. If I said, I want you and you, then there's 2 people. So you might think and means addition, but that's shit. And means this and this must be met. Fewer and fewer and fewer, right? Do you guys? Now, to be honest, I can't even write the idea of the formula yet. We didn't actually even apply a formula at all. We just counted. So we're not really using formulas right now. We're just counting the possibilities. There are formulas that we still have to talk about. Yes, ma'am.
So, like, regardless if it's or and, it'll never be the 22 or 27, it'll always be the 49.
Beautiful, I love it. So let's immediately do an example where the bottom is not 49. What's the only? How would I make the bottom 22? Somehow I have to tell you that the person you picked is a male. So the problem has to actually say that. It can't just go, you gotta know it's a man. No, they're going to say something like this. Everybody got this here?
Yeah.
Right?
You ready? So you're going to say, what's the probability that somebody said no, given they're a man? So people read this wrong. I wasn't given that they said no. How do you read this statement? What's the probability that they said no? Given they're a man. So what do I know about them?
They're a man.
They're a man. So now what could be on the bottom?
22.
Yeah, I know it's a dude, so I can throw all the women out. Yeah. Right? So now the bottom is going to be 22 out of those 22 people. So you can actually physically do this. Just cover everybody else up. That's your universe now. Out of those 22 people, how many said no? 14. And whatever the hell that is.
64%.
64%. Okay, cool. I like it. Take it to 10 decibels. Alright, so here, I'm going to give you guys another one to try. You guys got all this? So it's probably, let's see. It's probably their woman given they said maybe. Don't say anything out loud. Just take a second and write the answer down. Oh shit. You missed that over there. Poor people at home. Oh yeah, poor people at home. Did you miss it? Maybe not. Alright. So what goes on the bottom now?
9.
What are you given? That they said maybe. The question is, what's the probability they're a woman? So if they're a woman, there's 100%, and we're done. So I don't know if they're a woman or not. Given that they said maybe, 9 people said maybe. Well, 9's kind of gotten lost there. So out of those 9, because it's got to be one of those 9 people, right? Out of those 9, how many chances do I have for it to be a woman? 6. That's 66.7. Now watch this, don't watch that. What's the probability that I just pick a woman? What's probably just I pick a woman? I think we had this up here earlier, right? Didn't we?
Yes.
27 out of 49, which is 55%. Now, let me see if you guys get this. These are both questions about the probability that you pick a woman. Both of these questions are about picking a woman. One of them gives you more information, right? So the probability to pick a woman, period, is 55%. Did my likelihood of picking a woman increase or decrease if I know they said maybe?
Decrease?
What was it? What is it now?
66.
So did it go up or down? All right, it went up. It definitely changed, right? Do you guys see that? The probability that it's a woman changed if I know that they said maybe. So that would mean that saying maybe and being a woman are dependent. One thing happening changes the probability of the other. When people hear that word dependent, though, they think, oh, they have to have said maybe in order for it to be a woman. No, it's dependent just means the probability changes if the other thing happens. So for example, if I see somebody walking towards me and they're really far away, I'm like, is that a man or a woman? They're just far away. You with me? They're like right in front of me. They're far away. My husband, I don't know. But I noticed that they just got off of a Harley Davidson motorcycle. Right? So what's probably as a man or woman, before I noticed they got off the motorcycle, like 50%. Right? You guys with me? Roughly 50. It's not exactly 50 because biology knows men die more, so there's more men that are born, to be honest, but let's just say 50. And now they say, oh, they just got off a Harley Davidson. Is it still 50 or what?
More.
It's probably...
One. Close to one.
Do more men or more women ride Harley Davidson motorcycles? More men. I love it. Now, I always... Well, sometimes. Sometimes I get a woman get really upset at me. What are you saying? No women? No, I never. This is probabilities. This is not me saying, no women ride motorcycle and they shouldn't, blah, blah. It's just the probability it's a dude went up. So if I put money it's a dude and it actually comes out to be a woman, you're going to come back to me and say, your stats is shit. No, it's all probability, right? You guys understand? I like it, I like it, I like it. So when doctors run blood tests, very often the results are so not 100%. Because the chances that this is going on, given that they see this result, goes up. Doesn't mean that you definitely have whatever the hell that is. You get false positives and false negatives, all this kind of shit. You guys understand what's happening? So they can't say you definitely. It's just that the chances, very often the chances go really high, so yeah, you probably do. But it's almost never 100%. There could be other reasons for that happening. Or maybe. Okay. What else do I want to... Oh, let's do this. Okay. Let's do one more thing. We'll take a break. I'm going to unleash you on this handout. You know me. My handouts. All right. This is kind of a big thing. So, let's do this. Before I talk about this next idea, let's collect the formulas that we know. I wish I would have left that work up there that we did, but oh well. So to find the probability A or B, we actually added everybody in A, added everybody in B, right? Added those together? But then we had to subtract anything that was... That was both, right? So if it was women or no, I added all the women to all the no's, and I subtracted all the ones that were women and no. So the formula is officially this. All the A's, all the B's, but you subtract off any that are both. Think back, if you look at your notes, it's exactly what we did earlier with the OR problems. Visually, if you like a little Venn diagram, if I say A or B, if I take all of A and add it to all of B, I added part of that twice. What part did I add twice?
Middle.
The part that is A and B. So that's why you got to subtract one of those off, because I put two of them in there. That's not fair. Okay, I like it. Alright. Then we got the probability of A given B. Now let's do this one. This is the more interesting one. It's the one I should have definitely kept one of the examples up here, but too bad. What went on the bottom? Yes, ma'am.
Oh, that's what I was going to ask you. Are we, so for the first one, should we be putting the factor of the sum?
Say again?
Are we supposed to divide by the sum?
Oh, what's in each of these? What's on the bottom of this?
Right.
What's on the bottom of every probability is the total number. So these are already divided by the total. I like it. So this is, again, I wish. What was the first OR question we did? Look at your notes real quick. Male or
No.
no? And what was the results? I mean, what was the first step?
22 plus 30.
Oh, but so 22 plus. What was the?
17 minus 14 minus 4.
All right, now. All right, let me stop there. Right? Did you guys see that in your notes? You didn't take notes? Well, then too bad for you.
The first one was probability of winning.
Oh, this is fine. This is fine. I just needed one to work with. Now watch this. Isn't this... Stay with me. I don't care. I just need one to work with. Aren't these the same thing?
Yeah.
You can do it, Jeff. Isn't this the probability of males? Isn't this a probability of A plus probability of B minus probability of both A and B? So the probabilities have the 49 built in. That's why I didn't have to divide extra. Okay, good. So that was a good question, though, because it looks like it's missing that.
Okay.
But it's kind of like built in.
Okay,
Let
got
me
it.
let that sink in a little bit. Now the given, what was the first given one we did?
No.
No.
No given males.
No given male?
Yes.
Okay.
Because it changes.
So what was it? It was 22 on the bottom. So what seems to go on the bottom always? Why does it make sense about this? The thing that is given. It makes sense because whatever I'm given, I want to put that on the bottom. So on the bottom it's going to go, yeah, so the probability of B goes on the bottom. Now what's the only way you can get on the top? Did we put all the no's on the top? No, we only put the no's that were also males. So the only way you can get on the top, if I know men happened, what's the only way they could have said no is if they were a man and said no. So the top of the formula is going to be A and B. Visually, if I tell you that B happened, so I know this happened, what's the only way A could also happen is if it's here. Could this A happen? No, I told you this happened. So the only way that A could also happen is if it's in A and B. So that's the visual of it. Maybe. Possibly. Okay. Whatever the top of it. All right, so that's what we've done so far. So the last idea I want to do before we take a break is, what the hell is and? We actually have a formula that requires us to know and. Well, that's evil. So I can't use this formula unless I have a way to figure this out. So if I give you stuff to count, you just count it and put it in there. I don't even need a formula. So a lot of probabilities do not need a formula. If you could just count, if I give you all the numbers, you can just count and make your own probabilities. You guys with me? Just like we did earlier before we even knew these freaking formulas, right? Okay, maybe. So to kind of, let me start with the non-silly example. And then I'll do a silly example. Sure, Jeff. Okay. You're all like, just do what you got to do, man. So a while back, in 86, horrible thing happened in 1986. If you were born in 86, I don't mean that. So you guys are like, I wouldn't even thought of any of this, and that's for you. Yes, there you go. I lived in Florida during that time period, and we would go out and watch the space shuttle take off, and it was the coolest thing. That day, for some reason, I was in school. I remember when I heard about it, because I was a big time, obviously I'm a big geek, so when I heard about it, I all cried. That's when the space shuttle blew up, right? And for some reason, we didn't go out and watch it. For whatever reason. I think it was bad weather where we were, whatever. So we had to learn later that this happened, which is fine. So what am I trying to get at? Yes, ma'am. Sorry.
Oh, I was just going to mention that my uncle's teacher on that.
Oh, really?
Yeah, he was watching it
Damn.
on TV.
That's one of those,
Yeah.
it's going to be on that plane, and it was late, and then it blew up. Okay. Yeah, okay. Yikes. So, I don't know if you guys know why the thing blew up. It's because there were these things. I'm going to oversimplify this. So if there's any engineers out there, just lay off. Gas flow, you want to flow one direction, not the other, because then it's going to do what it did. So there's these things called O-rings. And let's say, just to make it really simple, let's say there's a 1% chance that any individual O-ring will fail. So the basic idea of the O-ring is gas goes one way, but if it tries to go the other way, it closes. I'm sure you guys have seen stuff like that where you can put something in one way but not the other. It's kind of like those where you pull a tissue out, and when you try to push it back in, it goes, no, ain't gonna happen. Right? Maybe. If not, then I don't know what to tell you. So what's the chances that this one fails? 1%. So, and why do you think I have at least two of these bad boys?
What's 2 is not 1/5?
In case one fails. In fact, that's called contingency plans. I can't remember the other words for it now. Failsafe, redundancy. There it is. Thank you. Right? You want redundancy. If you live in a really bad part of the neighborhood, you probably have more than one lock on your door, because maybe they can pick that one, but this is a different kind of lock. Maybe they can't pick this one. You're trying to reduce the chance. So obviously, if I say what's probably that both of these fail, you're not going to add these. That would be horrendous. You would expect the probability that they both fail to be smaller than either of them alone. Doesn't that make sense? So 1% of the time, this one will fail. How are you doing so far? So 1 out of 100 times, that one fails. Out of those times, this one will fail also. So 1% of 1%. So and means multiply. That seems counterintuitive, because normally when you multiply, numbers get bigger. But if you multiply numbers below 1, they get smaller. For damn sure. And that's why parabola curves the way it does. Let's not go there, Jeff. Too bad for me. All right. What is 1 over 100 times 1 over 1 over 100, right? 1 over 10,000, which is 0.10 hundredths, thousandths, 10,000ths. So 0.01% chance. And if I put a third one in there, I would add 2 more zeros in front of this bad boy. Add 2 more zeros in front. All right, now we're getting somewhere. Now we're doing some good shit. Let me stop there for a second. Does this make sense so far? Okay. Yes, ma'am.
It does make sense. I was just a little off topic. Were there 2 in the situation you're talking about, or you got to tell us that there were more?
There were more than the 2,
Okay.
and there were also other backup. Now, the day of, what happened was it was icy conditions, colder than they experienced before. We were all cocky because in '86 we had been like, we can shoot these off, they come back, everything's great. And since then we've lost. I was like, holy shit. We just were lucky. We didn't know. We were just lucky. So the day of, it was icy. These things iced up, which made them fail. So a 1% chance it's fail. But given that it's icy conditions, the probability they fail went way the hell up. They didn't take that into account. They all failed. The gas went the wrong way, ignited, blew up. All right. Everybody with me? Okay, good. Silly example. I don't even want to do this now because I think that one made total sense. But you're all like, just do the damn thing. Silly math boy. Let's say that I want to join a fraternity. And they're going to do some weird initiation thing. Thankfully, it's nothing too crazy. I got to walk down this hallway, and every 3rd step I take, somebody slaps me on that cheek. And every 5th step I take, somebody slaps me on that cheek. Right? So when am I going to get slapped on this and this cheek? How often will that happen? It will happen. Every 3rd step, bam. Every 5th step, bam. So the 6th step, bam. The 9th step, bam. The 10th step, bam. But there is a point, of course, where I get both. The 15th is the LCD, right? But how did they get there? 3 times 5. 1/3 times 1/5. There's a 1 out of 15 chance I'll get both. So and basically means multiply. Or basically means add. Do you see why I say the word basically? Because it's not the whole picture. Sometimes I got to subtract, right? And basically means multiply. Ooh, shit. There's still some extra twist that I haven't talked about yet. But I feel like I want a break right now, so I'm going to give everybody a break. Let's see what time is it. Come back at 5 after. Keep going.